Section 4.3, the fundamental theorem of calculus. Example number 1. If the function f is the function whose graph is shown below, and the function g defined as the integral from 0 to x of f of t dt, we want to find the value of g of 0, g of 1, g of 2, g of 3, g of 4, and g of 5. Then sketch the rough graph of g. So first of all, we find g of 0. So what all we need to do is look at this function, and g defined as the integral from 0, and then I will plug in the x, which is 0 right here, of f of t dt. We find the area of the same place, same point, because it's from 0 to 0, so the answer have to be 0. Then g of 1, which is the integral from 0 to 1 of f of t dt. So the area would be like this one. This is the area from 0 to 1, and that is the triangle. So the formula for the area is 1/2. This is 1, this is 2. So 1 times 2, and it's give us 1. G of 2 is the integral from 0 to 2 of f of t dt. Okay, so we have the area from 0 to 2, which is this. But we notice that we just calculate the area from 0 to 1 already. So that will be from 0 to 1 of f of t dt plus from 1 to 2 of f of t dt. From 0 to 1 we calculate, so we got 1 before, which is g of 1, which is this number, plus from 1 to 2, this is the rectangle, so you have the width is 1, the length is 2, so 1 times 2, and the answer is 3. Okay, so g of 3, so we have from 0 to 3 of f of t dt. So what is the shape? This shape, right? Okay, but we just calculate from 0 to 2, the red color, and the red color is the integral from 0 to 2 f of t dt plus from 2 to 3 f of t dt. 0 to 2, which is this, is g of 2. Okay, so we got the answer is 3. Approximately this part is about 1.3, and we get the answer is 4.3. So let me tell you the reason why the answer is 1.3 just for that little piece right here. If you look at the if you connect them and make like this, so this is like a triangle, right triangle, then the area of the right triangle is 1/2, 1 times 2, and the answer is about like 1. So the red piece, the red shape, is supposed to be more than that triangle, the area. So if the triangle, the area is 1, so it's a little bit more. So we just make the guess. Approximately is about 1.3. Okay. Now we have g of 4 is from 0 to 4 of f of t dt. That means that we can begin from 0 to 3 of f of t dt, which is the area of this shape. And we just did that in g of 3. Plus from 3 to 4 of f of t dt, which is the yellow, right? Okay, so the pink one we calculate is about 4.3. Look at the yellow. So the yellow is the same, symmetrical with the one on the top. So the yellow area have to be 1.3. We approximate before. However, the yellow, this one is in the bottom, so it's going to be negative 1.3. So the answer is 3. The last one is g of 5. The interval from 0 to 5 of f of t dt. So that is mean from 0 to 4 of f of t dt plus from 4 to 5 of f of t dt. Okay, so that means we have the answer for this is from 0 to 4. We calculate in sheet of 4 before, so that's give us 3. And this one, from 4 to 5, approximately is about 1.3, but it's in the below also, so negative 1.3. So the answer is about 1.7. Then we want to make the graph for the function chi. So look at the function chi. This is like a point 0, 0, 1, 1, 2, 3. 2 is the input and 3 is the output. And then 3, 4.3. So you continue to do that. The same thing for 5 and 4. Now let's look at the graph for the function chi. All right, so the first point is 0, 0, 1, 1, 2, 3, 4, 3, 4.3, 4, 3, and then 5, 1.7, and then we connect this, make a nice curve. Okay, so this is the function g of x, right? If you notice that at this point and it's at this point, we draw the tangent line, and that is the horizontal, so the slope is 0. And let's pay attention to this piece. So we have the graph is increasing, so chi of x is increasing from 0 to 3, and g of x is decreasing from 3 to 5. So that means if you take the first derivative will give positive right here. So the first derivative, it will give positive from 0 to 3, and it will give negative from 3 to 5. So let's go back to the function f. And you notice that right here at this point, the function f is 0 over there. And from 0 to 3, which is this part, the function f is positive. From 3 to 5, the function f is negative. So you have a feeling like the function f is the first derivative of the function g, and it is true. So we have the theorem below. Fundamental theorem of calculus, part 1. If function f is continuous on a, b, close interval a, b, then the function g defined by g of x equal the integral from a to x of f of t dt. X is between the closed interval a, b. The function g is continuous on a, b, and also differentiable on open interval a, b. Then the first derivative of the function g is the function f of x. Okay, so we make sure that the function f is continuous. So let's look at example number 2. Find the derivative of the function g of x. Okay, so this will be mapping from the theorem. So this is our function f of t, right? Okay, so what can we say? F of t, a square root of 1 plus t squared, is continuous. It is on real number because 1 plus t squared is always positive. And also function g is defined as this thing right here. So then what happened is by the fundamental theorem of calculus, part 1, we have that the function g prime of x, the question asks us to find g prime of x, is equal to the function f of x. But f of t is here. What all you need to do is you just replace the t value by the x value, okay? So it's equal to the square root of 1 plus x squared.